Our focus today is on the midpoint formula and the distance formula. Now, the midpoint formula is used to find the point that's in between. It's the point that's perfectly in the middle of the segment. And we will also be able to use the midpoint formula to find the endpoint of a segment. Secondly, we also want to be able to work with the distance formula. And we're going to see that the distance formula is the Pythagorean theorem. It really is nothing different. It's just the Pythagorean theorem written out to fit a very specific context of points in the coordinate plane. The three pieces of vocabulary we have, we completely expect you, by the time you've got to geometry, we know that you've been exposed to these before. Coordinate plane, leg, and hypotenuse. Just as a quick review, what is the coordinate plane? It's this thing where we can plot on the x-axis the left and right coordinates. On the y-axis, we have the up and down coordinates, and we know that they are plotted like a pair, 2 to the left, up 3. If we have the point labeled A, we would label it A. As we observed in the warm-up, if you want to get something that's in the middle, for instance, we were looking at what's in the middle between -2 and 6, you can add them together and average it out. Averaging is a way of finding something that's in the middle. Well, that is the very point, the main idea behind here with the midpoint formula. Now, if you want to pause the video and write all this stuff down for your notes, go ahead. That will be time consuming. The important characteristic for you to note, though, is the formula right here. This midpoint formula is built on the idea of an average. If you want to have the point that's perfectly in between A and B, you will have to take two averages. Because there is a distance going to the right, you can get the average and get the middle x-coordinate. Similarly, there is a distance going up or down. And if you average out those two different heights, you can get a height in the middle. If you get the average left and right, and you also get the average up and down, together, those two things bring you right over to the midpoint. The midpoint is nothing more than getting a pair of averages. And I'd also like to observe, when we get the midpoint, you notice this pattern of having two triangles that are the same size? We can use this two triangle the same size pattern to help us get answers more quickly than sometimes the formula will. Of course, this pattern is usually based on having a picture to look at. If you don't have the picture, it's harder to use that. So let's start right here. It's not required to draw pictures, but a lot of times students, it's easier for them to visualize what's going on if the picture is there. So just as a helpful hint, let's draw a picture so we can better understand the problem. And we're also going to note, or I'm going to note that I'm not trying to do a really awesome job with my sketch here. I'm not measuring it out perfectly. I'm not making sure everything's straight. We're just doing a quick sketch so that we can get a big picture idea of what's going on. All right, so let's start with our points. Point P is at -8, 3. 1, 2, 3, 4, 5, 6, 7, -8, and 3. So here is our point P. We also need to graph Q. 2 to the left, 1, 2, 2 to the left, up 7. And we have our point Q. Those are the endpoints of a segment. What we're trying to determine for the midpoint, what are the coordinates? Our midpoint formula tells us all we have to do is average them out. Look at the two x coordinates. -8 and -2. Add them together. What's -8? What's -2? -10. -10 cut in half gives us -5. With a good accurate drawing, if we drop this straight down, we would be at -5. We now have to do the exact same thing for the y coordinates. 3 and 7. What's 3 plus 7? 10 cut in half is +5. So if we come straight across, we'd be at a height of +5. These two pieces in the yellow and red, that's how we get our coordinates. Our midpoint is located at -5, 5, and we're completely done. All right, so this is one that we mentioned that for many students, drawing the picture is helpful, but it's not necessary, so I'm not going to do the picture here. We're noting that the midpoint formula asks us to add together the x-coordinates and divide by 2. Let's do that step first. Our two x-coordinates are -2 and +5. We will add those together and divide by 2. What's -2 plus 5? 3. And 3 divided by 2? 3 divided by 2 equals 1.5. That sequence of number crunching has given us the x-coordinate for the midpoint. We now have to do the exact same thing with the y-coordinates. Take the two y values, add them together, and after adding them together, cut them in half. So here we have 3 and -3. So 3 plus -3, that's 0. 0 cut in half. And so we're done. We have the coordinates for our midpoint. Now, this can also be used to find the coordinates for an endpoint. And like before, I'm going to show you two different ways of doing it. One way is based on using a graph. It's been my experience that to find an endpoint, most students prefer using the graph. But we'll also see how we can use algebra to do it also. And so let's start off by getting our picture. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. And now we'll plot our 2 points. M is the midpoint of xy. X has coordinates 2, 7. M has coordinates 6, 1. And we're searching for the coordinates of y. Please note what's going on then. We have our endpoint, we have the midpoint, and if we extend it further, somewhere down here, we are trying to find the coordinates of the other endpoint. Where are they? Well, one of the main things I'd like to observe, we can take advantage of this pattern that I noted before. I mentioned before that we are going to have two triangles that will be the same. We can take advantage of that and say there will be a triangle here where we have to go down, and to the right. Doing the exact same thing, we can go down more and right more, and that will have to be two of the same triangles. The key characteristic that we have to determine is how far down did we go and how far over did we go. If we know how far down and how far right, we can just repeat that and get our endpoint. And so what we're checking, right, since we're trying to match this down and right pattern, we of course have to figure out how far down did we go. Or 6. We can identify that by saying 2 goes over to 6. How much of a change was that? Okay, so that is telling us that we went right 4. We also have to figure out what was the change in the y value.
Minus 6.
So that's telling us that it went down 6. Identifying our pattern of right 4 and down 6,
Oh, I see. Yeah.
we can now apply it right here. Right 4, down 6. What's 6 plus 4? What's 1 subtract 6? Those are our coordinates. We're done. We can get those coordinates just by mapping through the pattern. It's been my experience that most students will prefer this method as opposed to the algebraic method that I'm going to show you next. And in fact, with our next problem, because so many students that I've seen don't like the algebraic method, we'll probably only do half of it before you tell me that we don't want to finish the rest. But we still have the same technique. We are given the midpoint, and we want to find the endpoint. And so we're noting R is the endpoint, S is the midpoint. One of the things that we can use is this component. The midpoint for the x-coordinate comes from here. Our second method can actually take advantage of the coordinate for the midpoint formula. Because we have the endpoint, we can plug in the x-coordinate for the endpoint. We also have the x-coordinate for the midpoint. And so we can put this in for the midpoint. What this does for us then is it gives us an equation which we can now solve. To solve it, we'll have to multiply by 2. And then we can add over, and it gives us the x-coordinate for the endpoint. All of this work is used to get only the x-coordinate. We would have to do the exact same thing with the y-coordinates to get our final answer. And what I'm hearing from you guys, what I've heard for a lot, this is too much work. It is a valid technique. It's completely correct. But what I've noted, of course, is that most students prefer just to take advantage of the pattern instead of taking advantage of the formula. To go from -6 over to the midpoint of -1, and please be sure that you're careful here. We have to go from the endpoint to the midpoint to make sure that we have the correct direction. If you don't get the direction right, you're guaranteed to be wrong. Well, how do you go from -6 to -1? That's saying add 5. So we'll have to add 5. which is -4, exactly what we just obtained. Do the same thing for the y coordinates, from -1 to +1. That's adding 2. Thus, we have the coordinates for our other endpoint. It would have to be at -4, 3. The second objective we had today was to be able to calculate the distance in the coordinate plane. And this is the distance formula. I'd recommend that you pause the video, write it down for your notes. Now, we are going to wind up showing that this distance formula, which you just copied down, is actually the Pythagorean theorem. And most students remember the Pythagorean theorem as a squared plus b squared equals c squared. I would like to caution you, do not memorize it in terms of a, b, and c, because you have to know what a, b, and c represent. The Pythagorean theorem applies only to right triangles, and it's better thought of as leg squared plus leg squared equals hypotenuse squared. Inside our coordinate plane, you know that down and right stuff that we were looking at before? Down and right, or left and up, or whatever they happen to be, those are legs of a right triangle. And when we're looking for the hypotenuse of the triangle is actually the distance between 2 points. Thus, when we are working with or trying to determine the distance between 2 points, we can use the Pythagorean theorem. It is the exact same thing, just written with different variables. All right, so here's our problem. How far apart are these 2 points, D and E? And we are going to do this 2 different ways. We will do it with the distance formula, and we will do it with the Pythagorean theorem. To start with, we're going to use the distance formula. The distance formula tells us that we have to subtract the 2 x coordinates and square them, subtract the 2 y coordinates, square them, and progress from here. So, we have x1, y1, x2, y2. It does not matter which is point 1 and point 2. But for what we have here, we'd have -2 subtract 3 squared. -5 subtract 4 squared. This is our distance formula. We've plugged everything in. Now we're just doing number crunching. What is -2 subtract 5? 3. Okay, so -5 squared. What's -5 subtract 4? -9. And so we wind up with 25 plus 81, which is 106. And we have our correct answer. No. If you could simplify the square root, of course, that's preferred. This one, since 106 is 2 times 53, the root would not simplify. And if you put it into a calculator, I'm not certain about this, I'm taking an estimate. I think this would be about 10.3. Alright, now we're going to come back and do the same problem, but instead of using the distance formula, we will use the Pythagorean theorem. The main characteristic behind them, we have to determine the length of the legs. So to go from -2 over to +3, how far right do you have to go? do that with 3, subtract -2 to get 5. That's one of the legs. We also need to determine the length of the other leg. How far up? And so here we're going from -5 up to +4. 4 subtract that -5 would give us a distance of 9. And so when we start crunching these numbers, 5 squared is 25, 9 squared is 81, and I'm hoping that those numbers are looking familiar to you. We just encountered them. 25 plus 81 equals 106. When we take the square root, we're done. We get the exact same answer with a lot less writing. The key characteristic behind this, it is the Pythagorean theorem, it is the distance formula, but the distance formula doesn't instantly say what is the length of the side. The Pythagorean theorem requires you to figure out the length of the side yourself, whether you do counting, whether you use subtraction, figure out the length of the sides, and the distance formula will just say, go straight to it, don't even worry about it. Okay, the question was asked, is there any time when the Pythagorean theorem won't work? No, because it doesn't matter what coordinates, it doesn't matter where you put the points in the coordinate plane, pick anywhere you want, and if you come straight over and straight up, you will always be able to create a right triangle. And since you can always create that right triangle, Pythagorean theorem will always work. That's exactly why the distance formula works. The distance formula is the Pythagorean theorem, it's just written out with more variables. That way it's more plug and chug instead of thinking. Alright, the last thing we have then is this example for how the coordinate plane and distance can be applied. The player is going to throw the ball from first base over to a point between third and home, located 10 feet from third base. Okay, so that's putting us at a spot like that. What is the distance of the throw rounded to the nearest 10th? Thus, what we're trying to determine, what is this length in yellow? From first base over to this spot, that is a gap of 10 feet. What is the length in yellow? Of course, the main thing we have to observe then is that we can create a right triangle. The blue one was there to help us find the correct spot down the third base line. When we actually go to create our right triangle, we can see that it's here, giving us a length of 90 and a length of 80. The blue was just there to help us figure out how far the 80 actually is. So since we have this right triangle, we can now go through and use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Oh, you still use 6,400 and 8,100. When those two things add together, we get 14,500. And then we take a square root. That is our answer. The length is 14,000, the square root of 14,500. But since the directions asked us to round that to the nearest tenth, we'll put this into our calculator and get 120.4415. When we round that to the nearest tenth, we actually get 120.4 feet, which finishes all the material we need.